Okay, we're going to tackle a topic here in this video that's one of the most misunderstood things in all of algebra. And I'm going to do my best to show you where it comes from and why it exists, and then we'll worry about some shortcuts that might make this a little quicker. So I got a few problems here, and they all relate to the same thing even though they all look totally different. Now we're going to start with this first one. Okay, we're going to look back at what this means. Okay, the way we've done this before is we've said, okay, a squared is some number, it's a times itself, a times a. Now, a to the fifth on the bottom, well, that's a times a times a times a times a. I got 5 of those multiplied together. And in past lessons, what we've learned to do is just sort of, well, remember, we're dividing these things. So we say they cancel out, but they really equal 1. And what we're left with is 1 over a cubed. Now, a lot of people are able to understand that concept, but then when it's written a different way, it really bugs them. Okay? I'm going to show you what's happening here. We had a shortcut that went along with this particular thing. Well, we said, well, hey, if this is the way it always works, okay, then let's see if we can develop a quicker way to approach it. And we said, why don't we just subtract these exponents? And a lot of people are fine with that as long as they get a positive number. Then when it's a negative number, they kind of freak out a little bit and say, oh, I don't know what this means. Well, let's look at what it means. Okay? If I were to do that, I would have a to the 2 minus 5, which equals a to the negative 3. And what I want to focus on in this video is that this right here and this right here really mean the exact same thing. And it can be written either way. Now generally when we say let's simplify something, we are really talking about turning negative exponents into positive ones without changing what they mean. So let's look at how this affects some of the problems you're going to be working with. If we look down here at the second one, we notice there's a negative exponent. Okay? Now the first question I have is, what does that negative exponent apply to? Does it apply to the 4 or just the x? And the answer is it applies to whatever comes directly in front of it. So it really is attached to that x. It has nothing to do with the 4. Okay, the 4 has its own exponent of 1. And what that means is, let me just think about this for a second. I have this 4 to the first power. Okay? And that's multiplied by x to the negative 2. Now if I remember this relationship right there, x to the negative 2 is really 1 over x squared. So this could be written, now remember 4 to the first power is just 4, and there's really a 1 underneath it, even though we never write it. You can divide anything by 1 and it's still the same thing. So this is really 4 stays on top with x squared on the bottom. Okay, what I would like you to be able to do is eventually go from here to here in one step. Okay, we may not be there yet, but we're moving in the right direction. Let's take a look at the bottom one. Okay, now if I focus on this principle, and I know that a negative exponent like this one right here really means that I have to take the reciprocal to make it positive, well, that still applies down in the bottom problem. Okay, now you look at this part right here and you go, okay, those don't have negative exponents, I don't have to change them at all. But b to the negative 7th, I can make that positive by taking its reciprocal. Now I'm going to show you the real shortcut to this. I'm going to flip it just like I did right here, but I'm only going to flip the part with the b for my base because the b is the only thing that has a negative exponent. So what I'm going to do is I'm going to flip this, and it's really going to come to the top of the fraction now, but it's now positive. So this is really 3a squared b to the 7th all over 1. Or we can just write it as 3a squared b to the 7th. We don't need to put that 1 in there. Now these are just a few examples. What you're going to see in some of these lessons, practice in class, a whole bunch of different variations of this. Okay, but you're going to see negative exponents show up, and what you really need to think about is, how do I make that positive? It doesn't mean it's an actual negative number. It just means it's probably really small, and it's a reciprocal. And if we can turn it from this into this, we're on our way.